Hello, everyone, and thank you for joining today's webinar, Circular Construction. As you get settled, please feel free to say hello and where you're joining from in the chat today. To qualify for continuing education credit, AIA California provides the learning objectives for every webinar and includes them in the PDF presentation that can be made available online. We will provide links in the chat box where you can find upcoming and on-demand climate action and ZNCD webinars from AIA California. A few quick housekeeping reminders. Today's session is being recorded. Additional resources will be made available on our website. Today's session qualifies for one AIA HSW learning unit for those who stay on and watch live. AIA California staff will report these units for you. Please use the Q&A function to ask any questions for today's presenters. You can also like a question to move it to the top of the queue. Cultivate a positive learning environment. Please be constructive in your questions and comments to help foster a positive learning experience for everyone. Finally, AIA California is happy to share that our climate action programming is now being brought to you by Arup. Sustainable design is everything. I wanted to make sure that we put up the learning objectives because I think my slides got messed up. I'm so sorry about that. And thank you for Fred Marks for being our moderator today. Fred Marks, FAIA, is a visiting scholar and research collaborator at the Salk Institute for Biological Studies in La Jolla, California. Mr. Marks is a founding member and past president of the Academy of Neuroscience for Architecture, and as well as an advisor for the International Arts and Mind Lab at Johns Hopkins University Medical Center. He is a past president of AIA Palomar in San Diego County, a current member of the AIA Climate Action Education Subcommittee, and a current advisor to National ASHRAE for its Guideline 10 document. Fred, thank you so much for being here, and I'll hand it over to you.
Great. Thank you, Sarah, and good afternoon to all attendees. In case you didn't see it, Metropolis magazine published an article last week on October 9 entitled "McDonald's Reimagines Its Interiors Through Radical Circular Design." And I thought to myself, is this the same McDonald's that gave us the iconic acrylic glass arches? It turns out that a pilot program is being launched by McDonald's in France and Belgium that aims to create sustainable interior renovations for the global fast food brand. So how does circular design relate to circular construction? And what can we expect in the future for our industry? To help answer these questions, I've invited 4 panelists of varying backgrounds and expertise to cover today's webinar topic. Felix Heisel is an assistant professor and director of the Circular Construction Laboratory at Cornell University's College of Architecture. Dan Stein is director of design technology at Lake Flato Architects in San Antonio. Lake Flato, incidentally, leads the AE industry with 15 Code Top 10 awards. Dan Bertzigal is the sustainability lead for the international structural engineering firm Schlake Bergerman. And finally, Mike Gable is the founding executive director of Construction Junction, based in Pennsylvania. Felix, would you please begin the panel presentation? Thank you.
Yes, I'd love to. Thank you so much for the invitation and being a part of this fantastic panel. If you wanted to advance the slides. I think you asked a really good question, Fred, and I'll try and answer part of it with some additional comments. But I think it's always important to zoom out a little bit when we start a presentation like this to understand sort of the grasp of the problem that we're talking about. And so if we look at our industry, at buildings from the very beginning till the end of their life, then we estimate that about 50% of the materials that we take out of the Earth's crust, about 40% of solid waste that we're generating, and about 40% of carbon dioxide emissions can be attributed to the built environment. Next slide. And there is something really important in these numbers, but I think it's even more important to look at those over time at a kind of time scale. And so what you see here, and I'm sure many of you are familiar with this, is a chart by Architecture 2030 about sort of the speed of reduction in carbon dioxide emissions that the built environment needs to somehow manage to stay within the Paris climate goal of 1.5 degree warming compared to pre-industrial times. What is really important to look at is that we're talking about a 65% reduction prior to 2030. So within the next basically couple of years. And if we look at our industry, we know that it is a sometimes very slow moving industry, and 5-6 years can actually mean the planning and construction of one building and not 10 generations of building designs. And so we need to act really quickly. Next slide. And so if we ask ourselves, what is sort of the largest impact or the quickest impact in moving the needle, then the circular ecosystem is one answer to this. And specifically reuse, because reuse is the most local and most direct of the circular strategies that we have to choose from. And I'll get into more detail why reuse is so much better than recycling, for example. But what you see in this diagram as well is the main goal, of course, is the phasing out of the linear system. So we're reducing the amount of raw materials that we're sourcing. We're reducing the amount of landfill that is generated through the closing of loops. Next slide. And so one aspect of this new loop is the question, how do we generate materials if we don't take them out of the Earth's crust? And so the built environments, the existing structures are our new mines, the urban mine, with the problem that none of these buildings were designed to be disassembled, at least very few of them were. And so urban mining quite literally means that we're taking things apart that weren't meant to be taken apart. And there is a struggle in that action. And so instead of demolition, what we can talk about is deconstruction as a sustainable alternative to taking our buildings down at the end of life, and with the goal to really activate material resources at their highest utility and value. If you go to the next slide, we wanted to understand what that means. And so we actually did a case study in the Circular Construction Lab. This is a building, it's called the Catherine Commons Deconstruction Project in Ithaca, New York, where we took a building apart, and the developer had one condition, that this project wouldn't cost him more than a demolition would, and it wouldn't take more time than a demolition would. And those are actually the two criteria that are one of the most difficult to fulfill in a deconstruction project, because they're usually more expensive and they're usually taking more time. And so we partnered with Dave Bennick here, which I'm sure some of you know, one of the leading deconstruction experts in the nation, to use a panelized deconstruction method, which essentially cuts a building into the largest possible pieces to bring them offsite as quickly as possible. And on the next slide, you see how we're taking down the gable wall with mechanized tools, right? To fulfill that. And if you go to the next slide, the final result of this case study was essentially that, yes, we are able to take down a house in 5 days, which is more or less compatible with demolition, a couple of days more, but it's not exorbitantly more. And the revenue that was generated from the resale of the materials that we generated in the deconstruction offset the additional labor cost that is, of course, part and should be part of a deconstruction project. And so next slide, what that meant for us is actually, this is really good news, because now we can talk about the things that we really want to talk about, right? So we're time competitive and we're cost competitive. Now, what else does deconstruction offer to us? And that there's a long, long list. If you compare deconstruction and demolition, deconstruction really offers sort of an economic potential. It boosts the economy through new jobs. It creates a green workforce. It's a really good workforce development program. It generates affordable and low embodied carbon materials. It supports climate goals, sustainability goals. It's capable of diverting waste from the landfill. And it protects public health because deconstruction projects tend to do a much better job in taking care of contaminants that are in the buildings compared to demolition. Next slide. Apart from that, if you zoom out even more, then there are another set of benefits that deconstruction can offer over demolition in terms of economic resilience, the wages that are paid per person, the jobs that are produced per ton of material, et cetera, et cetera. What I'm just showing right now are all numbers and slides taken from a recent white paper publication that just came out 2 weeks ago. That was published by the Circular Construction Lab in partnership with the Just Places Lab and CROWD. CROWD is an acronym for a partnership, stakeholder partnership in upstate New York, circularity, reuse, and zero waste development. And so in that partnership, we just published a white paper, which is free for download and kind of hopefully a resource for everyone that's interested in the economic potential of deconstruction and the strategies and recommendations, policy recommendations that are necessary to reach deconstruction at scale. If you go to the next slide, the summary, the executive summary of that white paper essentially goes into a bit more detail. So we did a rather detailed economic analysis of the potential of deconstruction. This is now for New York State, but of course, that's something that can be done for California or any other state where you're coming from and listen to this webinar today. And so what we estimate is that there's a $3.5 billion economic potential in a shift from demolition to deconstruction. We're talking 75% of current residential demolitions would be turned into deconstruction projects, and 12,600 new jobs in the state, et cetera, et cetera. Next slide. The white paper also includes 19 policy recommendations, which of course I can't go into detail today in this short summary, but I just encourage you to look at those. But they're sort of thinking along the full life cycle of a project or of a material, talking about the workforce, the market, the infrastructure, the question of what is the role of the state or the government to lead by example, and what kind of recommendations are necessary or policies are necessary to support long-term circularity across projects. Next slide. I'm happy to, I'll put the link also into the chat later if you're interested, but this is the download link and the partners that are that helped develop this white paper. Next slide. But since we're talking with architects in the room, I think there is another aspect, and that's design. And I think it's really important to mention some of these. These are the next two projects that I'm just covering very, very quickly, are projects from my office, 2HS Architects and Engineers. What you're seeing here is a little pavilion that we built completely out of reused materials. And if you go to the next slide, what I wanted to point out is the design potential of found materials, right? This pavilion, the structure of this pavilion would never look like this if we were to start with virgin resources. This is a struggle, a positive design struggle to develop something that works with the restraints that come with found material stock that is different, that is non-standardized, but it creates an aesthetic and it creates a different type of architecture, in my opinion, that is more responsive to the current conditions and the site and the location and the conditions that we're dealing with. Next slide. The other project I wanted to show you quickly is the Urban Mining and Recycling Unit, which is a project that we built with Werner Sobeck in Switzerland. And the unit that we're talking about is the sort of copper frame in the center of the image, which is a unit that is completely designed for disassembly. So every connection detail has been rethought so that all the materials that we put into this building can then be transplanted into another use, into another project at the end of this life cycle. Next slide. And the benefits of design for disassembly are, of course, the ones that I just mentioned, but there are many more. One of them, for example, is that we had only a one-day construction site because everything was prefabricated, pre-designed, and so we had modules that we lifted into the existing structure. A very happy client because we didn't have to close down the building. And so there's other benefits that come with circular design that I think are really important to mention as well. And next slide, just to kind of round this up, is a question: how do we evaluate this? We've been struggling with that question. And what you see here is a tool that we're offering at the Circular Construction Lab, which is Rhino Circular, which is a Rhino plugin that sort of constantly evaluates the circularity of a design while you're working in it. Like it's basically on your canvas, you see sort of an evaluation of the circularity. And that hopefully sort of triggers different design questions. That's the hope. That's an academic hope, but it's also relevant for the industry. Next slide, just to sum it up, these are some additional resources if anyone is interested. And with that, I'm passing it on to Dan.
Hello, thanks first of all to AIA California for inviting me to give this talk, and thanks to Sarah for her important role in pulling this together and advancing our slides. Next slide, please. Hopefully you'll be getting extra good vibes from my presentation since I am presenting live from my Airbnb in the Gaslamp district of San Diego while at a conference. Lake Flato is a B Corp, and recently our building that I'll be talking about later that you see on the screen here recently achieved WELL Platinum certification. I'll be referring back to this slide, so notice that we have a 3-story office building in San Antonio, Texas with an attached courtyard. Next slide. And interestingly enough, or exciting news really, in case you weren't aware, our founding partners, David Lake and Ted Flato, won the AIA 2024 Gold Medal Award this year. And in some presentations about the firm's legacy, David Lake has said a few times, notably, that some of our best work has been done in partnerships. And in that spirit, I'm going to talk about something that has nothing to do with San Antonio or with Lake Flato first, and highlight an amazing thing, I think, that I'm really excited about and happy to share in many ways. I talked about it earlier this year at the AIA National Conference in DC, is that San Antonio is the largest city in the US with a deconstruction ordinance. In 2022, the City Council passed an ordinance that all 1 to 4 family homes with the dates that you see on the screen there must be deconstructed by a certified deconstruction contractor and not mechanically demolished. Next slide, please. So the city put together a report that basically helped convince the City Council on why this was necessary. Next slide. Here's a few examples of some projects in the city being deconstructed. Interestingly enough, the city subsidizes the training for any contractors that want to become a certified deconstruction contractor. And their go-to training company is Repurpose Savannah, a woman-owned deconstruction company that comes to town for 2 weeks. And here I am on the left with 2 of our previous Lake Flato interns in the middle, and Katie from Repurpose Savannah, writing on a wall to be deconstructed on the process of deconstructing a building. Next slide, please. in the report that was created in February of 21, which can be found on the URL that was listed previously, there's several interesting things that are noted, including social and climate justice issues related to air quality and other properties around a building being mechanically deconstructed. Notably, the report highlighted that in 2020, enough quality lumber went into the landfill that could build 600 1,500 square foot homes. Next slide, please. One interesting technology layer that the city of San Antonio has added is the software by a company called Reaply, based out of Illinois. And that this is an important aspect of design, is being able to source these existing materials that can be reused. Another social and climate justice aspect that San Antonio has implemented is low-income families that have a 100-year-old home that want to fix them up and not tear them down have access to these materials for free. And like a book library where you can check out a book for free, you can check out construction grade tools for free, a hammer drill, a sawzall, work on your house and turn them back in, which is really amazing. Next slide, please. And so the city has a material innovation center, and which is where the materials would do go. The owner has the right to sell those materials or do something with them, but if they don't want them, the city will take them. And the city is repurposing an otherwise abandoned Air Force base. And you can see on the right, they have really big plans for growing this in the seventh largest city, which is competing for the 6th position against San Diego, I think, with how fast it's growing. Next slide, please. And switching gears, I'm on the AIA Committee on the Environment Leadership Group. At the national level, there's 12 of us that oversee all things COAT. And in 2023, the COAT leadership, a few members were tapped to work with an in-house attorney. So myself, Shell Anderson from LMN, Michelle Ampt from VMDO is the current chair, our past chair, Lori Ferris, RT Gouda from ZGF. We all worked to update the section "Architects are environmentally responsible" in the AIA public policy and position statement. And then kind of jumping ahead, you can see a few highlights of other really important things we added. But in the lower right, you can see circular economy, building reuse, disassembly, and design for deconstruction. Next slide, please. And so thinking back to that image at the beginning, when Lake Flato remodeled our own office, and we've been in it coming up on 2 years now, there was a 1-story parking garage that accommodated 18 of our 120 employees' cars. Well, not everybody drives, but 120 employees, and there's only 18 parking spots. So Lake Flato, being known for connecting buildings to environments, we decided to take this to do something significantly different here. Next slide. And so we created this beautiful outdoor courtyard that's used year-round in Texas. We've hosted farmers markets and various community events. Next slide. Here's the roof of the garage being deconstructed. Excuse me. In the lower right, you can see Ted Flato looking at a mock-up of how we're going to reuse much of this material. In the middle right, in the center, next to me is Jamie Sartori. And then to the right of her is Jennifer Korsovic. Jamie was the architect on our office remodel project, having the toughest job any architect can have, doing a design for a bunch of award-winning architects. Next slide, please. So in our office, you can see the downcycled structural wood used in the ceilings. And next slide, you'll notice between this slide and the next one, there's lots of materials that have been sourced that are existing materials. In the upper right, Ted Flato taught some of our interns how how to rope some existing chair frames. And on the left, in our phone rooms, the work surfaces are these, the wood from the ceiling, so you can rub your hand across them and sort of feel the nooks and crannies and think about the history. Next slide. And then we have a sustainability action plan that talks as a base goal for every project to think about design for deconstruction and reuse. Next slide. I'm already out of time, so I'm going to go through these quickly. I lead the research program at Lake Flato, and we have several research papers and a current one that we're working on with Felix and as an advisor on mass timber design for deconstruction. Next slide. So mass timber end of life scenarios is a recent paper we published on our website, and then on the right is the most recent designing for future climates. Next slide. And so the design for end of life scenarios that's published, you can see there's a section on circularity. Next slide. And then just to make it painfully obvious, the idea of deconstruction, as I highlighted it on this slide, and the little call out bubble from another page in the middle there talks about the second highest value is deconstruction. Of course, the number one would be adaptive reuse. Next slide. We have a project in Texas that's under construction. Next slide. That's going for sustainable sites, and it has credits that you can gain towards the certification when the building is designed for disassembly and reuse. Next slide. And then this is the final project. I believe this is one of our COAT Top 10 awards, and I must have given Fred old information because we're now up to 16 COAT Top 10 awards. This one won the award in 2006. Next slide. And in the AIA description on the website, it talks about this building being designed for deconstruction and disassembly, and notably low embodied energy. So nearly 20 years ago, we're calling it low embodied carbon now, but Lake Flato has been really making big, commitments in that area for quite some time. Next slide. That's it for me. Thanks.
Great. Thank you, Dan and Felix and Fred and Sarah. After Felix and Dan there have spoken about sort of academia and the design focus, I'm going to speak more about the structural implications of circular economy practice. And particularly, I want to talk about the three primary structural materials that we deal with: steel, wood, and concrete, and how these three materials interact with three circular economy principles. So let's get the next slide, please. So first a diagram. Felix showed a really nice diagram of the circular ecosystem in his deck. So forgive me for this less finesse total oversimplification. I think it's often useful to think about these four different construction economies as we talk about them. So first we have this linear economy, this direct red route. And this is where we're extracting resources, using energy, and emitting carbon in each of these black boxes. And then the material end of life goes to landfill at the end. This is kind of our default scenario according to 2018 EPA data. 70% of construction and demolition waste in the US for materials like wood, drywall, brick goes through this route. Maybe 20% for concrete and metals. Second, we have this large loop economy, this orange loop at the top, and this is dealing with things like recycling of metals in the construction industry. Also covers things like downcycling concrete. And this is better than our linear economy approach, but it still often requires a complete restructuring of the material. When we recycle steel, we shred it and we melt it to thousands of degrees before we reform it again. So it's not a waste of material, but it's a lot of energy is getting used in this stuff. Third, we have this circular economy loop in blue. And this is where we can make some smarter decisions at the end of life of a building. So instead of demolishing, we can look at deconstructing, and again reduce the number of stages that we're working with. By deconstructing, it allows us to reuse the materials as they are, avoiding all of that energy, that loss of structural value. And then finally, we have that title loop, the maintenance economy. This is sort of the adaptive reuse phase. Now, if you go to the next slide, please. What I want to focus on are these three different circular economy concepts within this. So if we look at the circular economy loop, we start with this designing for deconstruction. And this is at the outset of a new project, maybe where we're thinking about how to better manage the connections between those construction materials. When a building comes to the end of life, and maybe for a number of reasons, it's typically not because every structural element in the building is dangerous. Buildings are removed for all sorts of reasons. It's not because everything is beyond its useful life. So then there's the opportunity for urban mining in terms of extracting that material. And urban mining, this is typically talking about a structure which wasn't designed for deconstruction, but has been decided afterwards that it should be deconstructed. And that's the majority of the buildings that we deal with in our structural environment. And then the third concept there is designing with reuse. Now, this is the process of adjusting new designs so that they can take advantage of already salvaged material, as opposed to specifying new ones. So what we have is, these three structural materials: steel, wood, concrete, and these three concepts: designing for deconstruction, urban mining, and designing with reuse. And I want to kind of summarize the current state of the art of the situation here. And as spoiler, there's some variation between which of these materials are most effective for circular economy use at the moment, and which ones need a little bit of work. So if we start with next slide, please. That's steel. So in terms of steel and the circular economy, this is maybe the most mature material for structural reuse. This is because it's often steel elements are prefabricated in facilities somewhere else. They're connected on site in a often reversible manner, and steel has reliable and stable material properties. If we think of designing for deconstruction, not so many major changes need to be made to conventional design practice. This picture we have here is Stadium 974. That's a 40,000 seater stadium from the FIFA Soccer World Cup in 2022. And using small changes to typical design practice, this was designed to be entirely disassembled with the goal of being reassembled, reconfigured, and reinstalled at different locations. This is an enormous stadium project which completed using this design for deconstruction practice. And it's really because it follows quite simple methods, designing a simple repetitive frame, selecting generalized loading for your structure, using a modular and rationalized approach, which allows for replacement and rearranging of elements within the frame, and thinking about transportability requirements. So limiting the maximum size of your design elements, limiting the weight of individual elements, and thinking in the future about a tracking strategy. So where these elements can be stored and how they can be stored in a sort of digital way. So this is something which has been done on a few projects and is sort of mature for design on everything we work on. Urban mining is typically focused on structures that weren't explicitly designed for disassembly at the time. So unlike the stadium on the left, the stadium in the middle is a picture from the Montreal Olympic Stadium renovation in Quebec. Now the roof is being renovated at the moment and is currently being taken down. And what urban mining here allows us to do is work with the client to help them in deciding what materials have additional value for reuse, how to take them down in a suitable condition and store them for future reuse. This works really well for institutional clients who have a lot of space, who maybe have resources to invest in the community, or have a large site where they are working on many projects in parallel. So SVP working on this project at the moment, and we're having conversations with the client about what is the maximum feasible length of these elements that can be cut down. How can the ends, the connections be dealt with, and where could this material be reused for future projects that they have in their portfolio. And then the third aspect of steel, which is really great, is that it's a material which everyone's very comfortable using, and it can be tested easily with strength tests and chemical composition tests to determine how strong it is and its condition. So this picture on the right is a bridge which was obsolete in Paris, France. And as part of the Olympic program this summer, was essentially cut and reused on the same site in a different configuration structurally, with a different aesthetic and different structural system supports. But by using a local material resource in a slightly different way, we could avoid procuring new material. We could use sort of more normal testing processes that structural engineers and builders are comfortable using, and get that into avoid procuring new material there. This is really great for structures which haven't been subject to plastic deformation. So seismic is no good here necessarily, and also fatigue. So rail and road bridges are some of the few structures that are probably not so good for reuse of steel. Go to the next slide. The story with wood is a little bit different. Yeah, wood is interesting because intuitively this is understood as a very reusable material. Particularly if we think of design for deconstruction. We often use traditional carpentry methods like mortars and tenon joints or screws, and these are easy to imagine undoing. Other methods that we use like nails and adhesives, these are much harder. And when thinking about design for deconstruction for wood, we should be avoiding permanent connections which can't be undone. However, the Circular Construction Lab, we were dealing with designing for deconstruction for one of the projects Felix showed previously, and there are some structural challenges still with actually considering screws and fasteners that can be removed and reinstalled again structurally. So when we design wood screwed connections, we only design them according to rules that they're installed once. We don't think about removing them, reusing the same fastener, and using the same location. So we did some work here on comparing how screws perform and how connections perform in terms of strength and stiffness if the screws are removed and reinstalled in different methods and how that's done. So I think that there's good opportunities there for designing for deconstruction even if the codes and design requirements maybe lag a little bit. In terms of urban mining, I think Dan showed some really nice examples of wood material reuse in non-structural uses, and there's a really thriving urban mining scene of wood reuse for non-structural uses. And this is a picture from Sawkill Lumber, a warehouse in Brooklyn, which primarily deals with salvaging wood for use as cladding, for flooring, for furniture. Urban mining is definitely possible for wood, and the challenges that we see with steel in terms of time and cost of the process, these all need to be overcome by giving a more direct use for the wood, so that the urban mining facilities can be increased. But in principle, this is something which is already done, already exists, and is restricted by space and economic considerations on projects. Urban mining is really great for wood products because they only store carbon in their structure if they don't decompose. So our primary environmental focus should really be stopping wood from decomposing. And then the picture on the right is an example of designing with reuse. And this is a research project that SPP have worked on with the Circular Construction Lab on how to understand the design properties, the mechanical properties of wood, so that we can do structural design calculations within the code. And there's still a lot of work to be done here, but the work that we produced set out a feasible step of processes that we could use to get properties for design. And while we're working on this in the US, there's a lot of really good research coming out from Europe, particularly Norway, on how we can strength grade reclaimed wood for structural reuse. I'll talk quickly about the final material, which is in some ways the most exciting because there's so much new development. So we go for the next slide, please, Sarah. There's so much new development and research going on this, but there's a little bit less practical completion of projects. This really owes a lot of credit to the Structural Exploration Lab, who are a circular economy research group at EPFL in Switzerland, who have set out a few processes here for circular economy and concrete. So if we start with designing for deconstruction, there's some design for deconstruction for concrete primarily focused on precast materials. So precast columns, precast panels, precast slabs. These can function in the same way as the steel elements. They're discrete units that are connected together and can be disconnected on site. The challenges here is to avoid wet connections, using high strength concrete, grout, and cement mortars, and instead to look at bolted connectors or other ones with lime cements, which can be more easily removed. So designing for deconstruction with precast elements has been done. There were some buildings in the 80s, 90s, 2000s in Germany which used precast concrete slabs again. But this is still sort of limited to how those connections are worked with. Urban mining and designing with reuse, these are really opportunities for using cast in place concrete, and developing methods for how to cut the concrete apart and move it around and reuse it structurally. Now there are some obvious challenges here related to transportability and time on site when you're using these large saws to cut pieces apart. But as long as the distances that material isn't being moved are not too large, then I think there are really nice opportunities for taking complete concrete elements from our existing structures and using them with all of their complicated cast in place reinforcement and design in place. So the work at the Structural Exploration Lab at EPFL is it's a really exciting benchmark for what could be done if we can start to take this into our completed construction. So final slide, and then I'll pass on to Mike for the last panel section. Go to the next. Yeah, thank you. It's a really low-tech summary of where we're at. So if we think of our 3 circular economy concepts, designing for deconstruction, urban mining, and designing with reuse, these are all achievable with steel. Steel structural systems use these, and there's been a lot of really good growth in this market, and some great examples in Colorado and some really good work in the United Kingdom, with many commercial projects using all 3 of these aspects. In terms of wood, there's a little work still to be done. Designing for deconstruction is something that people are comfortable with in wood. Urban mining is feasible, but could do with some support. And that support really comes from structural engineers developing technical systems for designing with reuse. And that's a work in progress at the moment. And then finally, concrete. There's a lot more work to be done on concrete in terms of taking that research and putting it into practice. But I'm hopeful that in the next 5 years, we'll make some real progress. So it really requires you to keep in mind that you can propose these concepts on projects, and you can challenge your structural engineers to either do it or explain to you why they can't. Thank you.
Are we good here? All right. Good afternoon, everybody. Happy to be here. I am Mike Gable. I'm the founding executive director of Construction Junction. Construction Junction is a nonprofit building material reuse retailer located in Pittsburgh, Pennsylvania. And we have basically been in the trenches of doing building material reuse for 25 years. Next slide. So, oh, thanks. I don't want you to miss my quote here. I'm always looking for interesting quotes around reuse, and I found an interesting one from an unlikely source, Pete Seeger. If it can't be reduced, reused, repaired, rebuilt, refurbished, refinished, resold, recycled, or composted, then it should be restricted, redesigned, or removed from production. I think that about covers just about everything we've talked about already. Next slide. So here is a quick overview of Construction Junction, our mission to promote conservation through the reuse of building materials. We have a little over $2 million operating budget, 35 employees. We don't track materials by weight. We actually track individual items, doors, windows. We've diverted over 6 million items, and that's probably a gross underestimation because we also deal with lots of small pieces of hardware. During that time, we've generated $30 million in reclaimed building material sales, recorded 700,000 purchases of reclaimed items, and almost 80,000 since 2011, material donor engagements. So those are individuals that are asking us to do deconstruction or are asking us to send our trucks to their construction site to pick up building materials. Next slide. So here, this Construction Junction and organizations like it were really launched to address the issues of C&D waste. And I think it's important because we always throw around some really big numbers. It's really important to understand that the total amount of C&D waste generated, these are EPA numbers from 2018, the last column, it's about 600 million tons. But a lot of that material is concrete and asphalt, and a lot of it gets, and you can see underneath, you can see how that material, certain materials get repurposed, reused, not necessarily reused, but repurposed or ground up into aggregate or downcycled, and when we're talking about concrete. But then of that C&D waste, almost 144,000 tons, excuse me, thousand tons of material does get landfilled, and that's the part of the waste stream that reuse organizations are working to address. Next slide, please. So just a graphic representation of demolition obviously eliminates any possibility of reusing any materials at all. Next slide. So referring back to the other slide, in the building material reuse industry, where a lot of times we're looking at C&D recycling versus C&D reuse. And C&D recycling is really about maximizing weight. This is from my perspective of being involved in this industry for as long as I have. C&D reuse is really about maximizing the value of materials. So the big numbers on recycling, concrete, asphalt, raw wood, glass, plastics, you can see that the energy involved in that is expended in the transformation of the material. The industry is very centralized and mechanized. There are about 300 material recovery facilities in the United States that focus on, and those are material recovery facilities that are focused on recycling. And the direct revenue that industry is responsible for is about $7.4 billion. Now, compare that to entities like Construction Junction, and a lot of you have probably interacted with other building material reuse organizations. Hopefully you've got one near you. We're really dealing with building material components, doors, windows, plumbing fixtures. Our energy is expended in the labor to extract this material. As you've heard a lot of, this material is not, this material requires a lot of labor to extract, because these buildings and these interiors that we work on are really not built to be deconstructed. Our industry is decentralized, highly labor intensive. There are about 1,400 reuse operations in the United States. And our industry generates about $2 billion of revenue annually, so significantly smaller than the recycling industry. Next slide, please. So the biggest challenges that I've observed being in this industry for as long as I've been is really simply coming down to matching supply of used building materials with demand. I can't tell you how many times I've interacted with architects that have seen something at Construction Junction and said, do you have 5,000 square feet of that material? And I'll say, well, no, I actually have 2,000 square feet of that material. And there's not really a place I can go to get the rest of it. There's not a used building material catalog that I can open up and order from. So the challenge really is we've got a highly decentralized supply. We're looking at buildings, all the buildings that are already constructed. What's the inventory in those buildings? Timing, when or if those materials are actually going to become available. Communication, how much material do we have to work with? What is the quality? What is the useful life that remains in those materials? And the biggest question for me, having been involved again as long as I have been, and I was speaking to the executive director of AIA Pittsburgh, and she said, well, the biggest question is, well, whose job is it? Whose job is it to make sure that stuff gets reused? And how do we incentivize the building industry to manage that material to maximize its reuse? Do we need a chief reuse officer? And again, why I ask this question is I can't tell you how many times I've gotten phone calls from construction sites or architects or builders that have said, I've got a dumpster load of, or I'm getting ready to put 300 doors in a dumpster. Can you be here tomorrow to pick them up? That's basically telling us that it really isn't anybody's job. It's sort of an afterthought. It's very informal, and we're never going to scale this if we keep it at this level. Next slide. So how do we scale the reuse of building materials? What is the post-consumer supply of building materials so that architects can design to what is actually available? Next slide. So we tried to answer this question by having a consultant, Metabolic, from the Netherlands come out and actually do a look at the flows of construction materials that come into new construction and the outflows of demolition materials, and what is the makeup of those demolition outflows. So you can see the numbers there. Next slide, please. We looked at and broke down these materials, brick, steel, wood. So these are more raw materials than they are actually building material components. And then we looked at the quantities that made up the demolition stream of 85,100 tons. This data came from 2019 demolition permits for the city of Pittsburgh, and Metabolic has a modeling process that they use to come up with these numbers. Next slide. So then we asked them to actually come up with, well, let's break this down into actual components. These are the inventory items that an organization like Construction Junction deals with, and this is the first time that we had ever seen any kind of data that tries to quantify building components that are in the waste stream. We also looked at the embodied carbon that's present in those materials as well. So we looked at value of those items new, we looked at value of the items of used, what we would sell them for, and then we looked at carbon. Next slide. Supply strategies. The main one that I would highlight here is that we need more investment in reuse store and reuse infrastructure. We've already talked about some deconstruction ordinances. There are tax incentives that are involved in donating building material to nonprofits. We really need to require reuse audits. When you're applying for a permit, I actually think this is one of the most important things that we should be doing, because architects and contractors and building owners need to really understand what is actually reusable in their projects. And if we're not doing an audit, we can't really answer that question. We've talked about some specialized training for deconstructors. Landfill bans are in place in some places, and we've talked about design for deconstruction. Next slide. Demand strategies, we need to include reuse and specifications in bid documents. We need more predictable supply chains. We need partnerships. We need governments to specify reclaimed materials in their projects. We need to be able to do value added to materials that have low value, because there is a lot of low value material that comes out of these buildings when you do a deconstruction project. We inventory everything we take out. That little barcode at the bottom with the QR code tells where something comes from. We can tell how many times somebody's donated something. We can put all kinds of information within that code. Next slide. Here's some of that environmental data that collected during the metabolic study. You can see, again, because we track items, we have repurposed over 83,000 doors during the time we've been in place. You can see the tons, you can see what we've conserved in water and energy and CO2 emissions. We need to also look at what is the embodied carbon within reused building materials, so we can compare the environmental impacts of using a new material versus a reclaimed material. Next slide. And finally, I'll say that architects, you all play a huge role in the reuse ecosystem, because you are often the first people that interface with building owners. Next slide. So this next series of slides, my board president created, who is an architect, to show the process. Next slide. Of how an architect engages with an owner, with contractors, the different phases of design in a conventional process to get to occupancy that does not include any deconstruction or reuse of material. Next slide. The next series of slides is that same process with deconstruction integration. Next slide. So you can see where in that process, where you would put in a deconstruction assessment, where you would put in confirming the reuse potential within a current project. Are you going to keep reused materials within the project? Are you going to donate them to a construction junction? What are you going to do? And then once the contractor is on board, how do you engage the contractor in this process, particularly if you're trying to install used building materials? Next slide. So this is the big message. Get in early and make it easy. This is what we tell architects, that if you're going to promote reuse, you got to get in early. And we in the building material reuse industry have to make it easy. Next slide. I'm going to skip over the next slides because I can see we're running out of time. This is a project at Construction Junction where we have worked with architecture students to do design with reclaimed building materials. Next slide. And then finally, Build Reuse is a national organization that our members are building material reuse operations, and across the country, government folks, architects. I will call out here at the top that our Deconstruction and Reuse Conference will be 2025, August 4th through the 6th in St. Paul, Minnesota. Thank you.
Sarah, how much time do we still have?
So we are, for those who have stayed this far and watched live, AI California will report these units for you, and you can receive a certificate for today's program upon request by emailing me. If the speakers are available for a couple questions, we can stay on, but for attendees, we encourage you to stay on if you're available to hear any additional discussion. But for credit purposes, you guys are all set.
Okay. And there will be attempt to answer the questions, and I know that Dan answered a structural question in one case, but we can do that after the presentation.
Yeah, you're free to go through
Yeah.
any of the
Yeah,
additional
via the
Q&A
Q&A.
that's left over. Mhm.
Well, why don't we, since Dan just finished his presentation, start with him. Based on the national organization that you just referenced, are there construction companies like yourself that are now located throughout the United States and in particular in California?
Yes, there are there are deconstruction contractors working in California. If you go on to the Build Reuse's website, we do have a membership directory that will list out building material reuse operations that are all over the country. We also have a deconstructor training registry that's on our website. The reuse people are